So you also need to know that dot and cross bonding, the dot and cross diagrams for these oxides, right, to show the bonding within this oxide. So for aluminium, we can draw the square diagrams. This is the oxide ion, and then this one is the aluminium ion. So the oxide ion gains 2 electrons, and then the aluminium ion loses 3 electrons. And then we are going to have 2, since we have got 2 atoms here, and then 3, since we have 3 atoms here, 3, and then oxygen, and then aluminium, and then we show the charges here, 2 minus, and then we are going to illustrate the electrons and then use the key. So we should also take note that for dot and cross we must show the key, right? So here we're going to show that we gained 2 electrons, and then we are going to show the electrons of oxygen using the dots, and then the electrons for aluminium, we represent them using the crosses. So cross, electron from aluminium, and then dot, electron from oxygen. So this is the general display or general dot and cross diagrams for aluminium oxide. And then you do the same for other ionic compounds. And then for carbon monoxide, it is a dative compound, a compound formed by dative bonding. So we're going to have carbon and then oxygen. So this is the bond between the two. So dative bond, this dative bond is shown by an arrow, right? So the arrow shows, so you should take note of the direction of the arrow. So where the arrow points, that's where the receiver of the electron is. So the electrons are going to come from this oxygen to this carbon atom. So a dative bond, it is a bond whereby one atom donates both electrons to be shared during bonding. So this oxygen donates all the electrons needed to bond with carbon, right? So this is the bonding between carbon and oxygen in carbon monoxide. So a dative bond, it is a type of bond for period 2. It is only for period 2 elements to avoid the expansion. It is there to avoid the expansion of the octet. Why? Because the period 2 elements doesn't have inaccessible d orbitals, right?